page 2 of your chapter 8 study guide to prepare you for your vectors test. So number 16 and 17 are all about graphing in three-dimensional space. I ask you to graph each of these vectors. So again, even after this, if you still are struggling with this concept, remember I have links to just a graphing in 3D video that may help, or heck, go type into YouTube how to graph vectors in 3D, and there's some helpful videos on there as well, in case this is still a little bit fuzzy for you. Okay, basically what you need to remember is this is going to create it, because it's a 3D shape, it's going to create a prism. So in general, what you're going to do is, if you start at the origin and you're going to move in this direction, you're going to move 3 in the x direction, 2 in the y direction, 4 in the z direction. That means from this initial point, you're going to come forward 3, because that's along the x-axis. You're going to go to the right 2, and then from there you're going to go up 4. But it's like hard to imagine where these things actually are in space without being a little bit more precise about our measurements. So what I recommend you doing is, along the x-axis, the positive x-axis is toward us like this. So plot a point at 3. And then on the y-axis, we're going to plot a point at 2. And then what you're going to do is you're going to make a parallelogram with those two axes that are already there. So something like this. So there's a parallelogram that exists just between those 2 points. So that's the two-dimensional part. Adding in the third dimension is going to be up 4 on the z-axis. So with that point, you have a few more parallelograms to draw. So let's focus between the y and the z-axis first. So the y-axis is horizontal, the z-axis is vertical. So that's an easy one. That's just going to be a rectangle. And then the hard part is from here, finishing off the shape. Well, from this corner, we can go straight up to close in like the wall. That's on the left side. And then connect those 2 points there. And then same thing here in the middle. With this one, we can go straight up and then connect it there. And then these 2 connect here. So actually, these numbers are quite terrible, because if you're graphing a vector, that means you need to graph the point that goes from the origin to, again, if we follow along, so let's start at the origin. And then it's going to be, we're going to go forward 3, then we're going to go 2 along the y-axis, then we're going to go 4 up on the z-axis. So this green point is your ending point. Your answer is going to be the vector from the origin to that green point. So just do your best. It's going to look like this. Now, again, I picked terrible numbers that kind of covered up everything. So if that one confuses you, hopefully 17 is a little bit more spread out and it'll be a little bit easier to tell. Same idea. On the x-axis, we're going to come out 4. So graph that point. On the y-axis, it says -3. So it's going to be 3 to the left. And then just like we did before, I want you to trace out the x and the y-axis as they are. And then we're going to complete the parallelogram like so. So that's one parallelogram. Then we're up on the z-axis 6. So then your job is to create a three-dimensional figure from that plane to this point. So again, the z and the y-axis is going to be pretty easy, because that one's just going to be a flat rectangle. And then from there, again, we can close in the left wall if we just draw something straight up here. Draw that edge and then connect these. And then just connect this front face like this and the side face. So it's going to look something like this. If we start at the origin and we follow along the prism, so starting at the origin here, 4 in the x direction will take us here. From there, 3 in the y direction will take us here. And then from there, 6 in the z direction will take us here. So that final green point is your terminal point, and your answer is going to be the vector from the origin to that point. So in blue, this is going to be your answer. This is the vector represented by 4, -3, 6. Number 18, Dr. Alicia Sanchez is a researcher for a pharmaceutical firm. She's graphed the structure for a molecule with atoms having positions, and then it gives us A, B, and C. She needs to have every atom in this molecule equal distance from each other. Has she achieved this goal with the atom's current positions? Explain how you know. First thing to do is make sure you understand the concept of equidistant. It literally means same distance. So you need to verify, is A the same distance from B as it is from C, and are the distance from B to C the same as the other ones as well? So we just need to check those. Well, distance is essentially the same as magnitude, right? So I can go ahead and check the magnitude of the vectors that lie between each of those points. And it's going to be the same as distance. So let me just do A and B. I like point A because it has some zeros in it, so it's going to make the calculations a little bit easier. So magnitude of the vector created from A to B is going to be the square root of, now I don't have the vector components, so I'm going to do two steps in one. I'm going to subtract my x's, y's, and z's. So it's going to be x's with x's, so 1 minus 2 squared, plus the square root of 3 minus 0 squared. You don't have to write that if you know that's not going to do anything. Plus 0 minus 0 squared. Same with this term. You don't even have to write it. When we simplify this, we're going to get this 1 minus 2 is negative 1 squared, plus the square root of 3 minus 0 is just the square root of 3 squared. And that last term, 0 minus 0 is just 0. So when you type this in, or you simplify it in your brain, because it's not that difficult, you get the square root of 4, which is 2. So the magnitude of the vector from A to B is 2. So that's going to be our basis for comparison. Now we need to find another distance. Let's do A to C. Again, before I waste time checking all of the vectors, I would use A in every distance first because it's easier to calculate with those zeros. So from A to C, we're going to do the same thing. We're going to do the magnitude. C is going to be the second point, so we're going to subtract those minus the points in A. So it's going to be 1 minus 2 squared, plus y2 minus y1 is going to be 1/3 minus 0 squared, plus 2 square roots of 2 over 3 minus 0 squared. And then when we simplify, 1 minus 2 is negative 1 squared, plus 1/3 minus 0 squared is just 1/3 squared. And then same thing, the other minus 0 on this one doesn't make a difference. 2 square roots of 3 over 3 all squared. So it's going to be 1 plus 1/9 plus, it's going to be 4, it's going to be 8/9, I believe. Anywho, when we do that, so you're going to end up with the square root of 2. And then that is going to reduce to the square root of 2 is approximately 1.41. So the vector from point A to C has a magnitude of 1.41. You don't have to check the third distance if these two distances are not equal, because it says every atom has to be equidistant from each other. So at this point, we have our answer. No, her current drawing is not good enough. We can say A and B are 2 units apart. A and B are 2 units apart. And A and C are about 1.41 units apart. If they were equidistant, they would literally have the same distance. Number 19, Nadia is pulling a tarp along level ground with a force of 25 points, this should say pounds, directed along the tarp. If the tarp makes an angle of 50 degrees with the ground, find the horizontal and vertical components of the force. As mentioned before, anytime you have the ground as a part of your problem, that's going to be the horizontal component. So those two things typically will remain constant. The tarp is going to make a 50-degree angle with the ground. So we know that that'll be here. So if this hypotenuse, if you will, is considered to be the tarp, if it asks you to find the horizontal and vertical components, but it already gives you the force is being pulled with 25 pounds. I know some people have a hard time figuring out where should that be labeled. If I ask you for the horizontal and vertical components, I'm asking you for X for the horizontal and for Y. So the only other place to even put a number is going to be the force of 25 pounds. So again, that's imagining that the tarp is being pulled like this. Okay, and then if I want to solve for this, if I use SOHCAHTOA, or again, if you just kind of if you know the formulas for these without having to set up SOHCAHTOA, you kind of skip a step. But basically, if we do the cosine of 50 degrees, that's equal to adjacent over hypotenuse, so that's going to be x over 25, which means the horizontal component for x is going to be 25, oh, there are the dogs, times the cosine of 50. Make sure you're in degree mode when you type this in your calculator. You get that the horizontal component, x, is about 16.07 pounds. For the vertical component, we're going to just change our trig function to sine. Sine of 50 is opposite over hypotenuse. So that means we're going to do 25 times the sine of 50 to get the vertical component, which would be approximately 19.15 pounds. Number 20, what would the force required to push a 200-pound object up a ramp inclined at 30 degrees with the ground? So again, we have an object on a ramp on an incline. That object has a force, or what would the force need to be to push it? It's already acting with a force of 200 pounds. So that's why 200 is going to go there, because that object already has the force. It is on the ramp. It says it's inclined 30 degrees with the ground. So I know that this angle is 30 degrees. When it said, what would the force required to push a 200-pound object up a ramp, we are looking for this vertical force, which if you just want to be consistent with the vocabulary, we can put y there, because we're looking for the vertical force that it's going to be required to push that ramp, push that 200-pound object up that ramp. So then if we go ahead and set up an equation, we know that the sine of 30 degrees opposite over hypotenuse will be y over 200. So then y is going to be 200 times the sine of 30 degrees, which will be approximately, actually its sine of 30 is 1/2. So that force is going to be at least 100 pounds to get it up the ramp. Number 21, find the magnitude and direction of the resultant vector of the diagram below. This is by far one of the most challenging questions, and I guarantee it's going to be one of the most important and heavy-weighted questions on your test. I think some people kind of threw these at the window because like, oh, those are kind of difficult. It takes a lot of work, and the other questions are easier and quicker, but don't take for granted the ease of this one if you actually know, mentally what's going on and what you just need to solve it. So basically remember, if I want the magnitude and direction of the resultant vector, that means I'm adding these two vectors together. In order to add vectors, I need to know their components. I'm going to be adding the x with the x and the y with the y. So I don't know those components right now. That's why I'm putting question marks right here instead. Okay, so in order for me to find these components, I've got to use what I know about right triangles to make that happen. So let's go ahead and let's focus on this blue vector first. Let me actually color it blue. And I'm just going to call that vector f. Okay, so if I want to find the components of vector f, the horizontal components, I'm just going to call f sub x. And the vertical component, I'm going to call vector f sub y. So if I focus on that blue right triangle, and I want to solve for the horizontal component first. So then I'm going to say cosine of 19 is equal to adjacent over hypotenuse, or the x over the hypotenuse. So that's going to be f sub x, vector f sub x over, even though there's not a number here, they wrote the number at the tip of the vector, but that blue vector has a force of 10 newtons. So it's going to be 10. It's the magnitude. And then when I solve for vector f sub x, I'm going to get 10 times the cosine of 19. Well, when I do that, that's going to be approximately 9.46. So there's the first number of this vector component. The x is 9.46. To get the y, I'm going to do the same thing, except I'm going to change my trig function to be sine of vector f sub y over 10. So then vector f sub y is going to equal 10 times the sine of 19, which is approximately 3.26. So there's my y component here. So I'm going to erase the question mark. We know the y is 3.26. So I'm done with the blue vector. Now let's go over here to the green vector. This vector is at 112 degrees from standard position. Now the issue is I can't make a right triangle that has an obtuse angle of 112 degrees. So we're going to drop the altitude on the left side. And since I know that straight angles are 180 degrees, if I subtract 180 minus 112, then that's going to give me this angle is 68 degrees. If I refer to this green vector as vector g, then again, in order to find the components up here, I need to know what is the g of x or g sub x components and the vector g sub y components. The only thing to make sure that you realize is technically if this scenario of this vector exists in a coordinate plane, then that green vector is in quadrant 2. And in quadrant 2, I need a negative x value. Okay, so when you solve for the g sub x components, you just need to make sure that it is negative since you're in quadrant 2. So we're going to do the same steps as we did to find the x and y components of vector f. I'm going to take the cosine of my angle is 68 degrees. Adjacent over hypotenuse, it's going to be vector g sub x. The hypotenuse, again, is going to be that force of that vector, which is 6. So then the vector g sub x will be 6 times the cosine of 68, which would be approximately 2.25. So that's the x component. Again, since I'm in the second quadrant, that's going to be a negative 6.25, or sorry, 2.25. Negative 2.25. To find the y component, I'm going to do the same thing, but I'm going to change my function to sine. So g sub y over 6. So then the vector g sub y is going to equal 6 times the sine of 68, which will be approximately 5.56. Now that's that's the y value in the second quadrant. Y values are positive, so I'm going to leave that one as a positive 5.56. So now I've solved for the components of the two vectors on the picture. The question is, what is the magnitude and direction of the resultant vector? Well, the resultant is found by adding these vectors. So we are literally going to add, let's do the blue vector, 9.46, comma 3.26, plus the green vector's components are negative 2.25, and then 5.56. So when I add these, x with x and y with y, 9.46 plus negative 2.25 will be 7.21. Y with y, 3.26 plus 5.56 will be 8.82. Now, that's not my answer. That's the resultant vector. That's where it is located. When it says find the magnitude of that, we need to take the square root of its components squared. So the square root of 7.21 squared plus 8.82 squared. And then we'll round that to the nearest hundredth. We're going to get 11.39. Now, magnitude in this case is dealing with our forces. Forces in the given picture are being measured in newtons, so you need to make sure you put your units on that one. It's going to be about 11.39 newtons of magnitude on the resultant vector. The last thing to take care of is direction. So for direction, I want to draw where the resultant vector might be. So again, if your resultant vector, this will be the x and the y axis. If your resultant vector is at 7.21 and 8.82, I mean, it really doesn't matter where that is. But the bottom line is its x component will be 7.21. Its y component is 8.82. Well, if I have a right triangle and I'm trying to solve, remember direction, as we talked about on the front side, is the angle between that vector and the x-axis. If I put theta there, if I want to solve for theta, I can set up a tangent ratio. I can say, well, I know tangent of theta is y over x, or opposite over adjacent. So it's 8.82 over 7.21. And then to isolate theta, to get theta out of the tangent function, I'm going to do theta is equal to tangent inverse of 8.82 over 7.21. When we type that in our calculator, we're going to get that theta is going to be approximately 50.76 degrees. Very long question, but not very difficult once you kind of break it up into pieces and figure out, which parts you need. And even if you wanted to use colors on your test, as I kind of did to keep all the blue vector components together and all the green vector components together, that's fine too. Last question on the page. Write a vector equation of the line that passes through this given point and is parallel to this given vector. Then determine the position of the point when t time is equal to 8. Well, if you recall, a vector equation has I'll say the template. It's kind of like slope-intercept form. So a vector equation is going to be x2 minus x1, comma y2 minus y1 is equal to t times a1, the vector a1, a2. So this is the template. Okay, if I'm asking you to write the equation with this given information, then you simply need to plug in your point. Okay, so this is an x and a y, and this is already the vector a. So it's kind of like when you do point slope form of a line. You would simplify it down to be x minus, this one would be like your x1 and y1. So it'll be x minus 1, y minus 5 on the left side is equal to t, you need to leave t as a variable right now, times the vector a1, a2 will just be negative 7, 2. This is the answer to the first part. That is a vector equation. The second part, when it says t equals 8, that's where you plug in 8 to your vectors and then solve for the position. Okay, so to do that, let me pick a different color. When time is equal to 8, that implies, now I'm going to break this up into the x and to the y. So if I use my x coordinates, this is going to be x minus 1 is equal to, on the right side, the x term, if we distribute this scalar of t inside, it's going to be negative 7t. So that's the x's. We do the same thing with the y's. The y minus 5 is going to equal, distribute that scalar of t, 2t. So then our job is to substitute in 8 for t and then solve. So if we do that, that's going to be x minus 1 equals negative 7 times 8 is negative 56. If we add 1 to both sides, we get x is equal to negative 55. Do the same thing for the second equation. Y minus 5 equals 2 times, if time is 8, is 16. Add 5 to both sides. Y is equal to 16 plus 5 is 21. So the coordinates at time, 8 seconds, will be negative 55, 21. So there's the second part to that answer.